Hello, my name is Vincent Byrne and my project is APAVS. It's an automated pipeline and visualization system for load port qualification data. I work currently as a technician in Intel, and this project hopes to automate a manual process that currently requires connecting to each tool individually and running an Excel macro. This would also include like visually inspecting each of the results without kind of having a fleet-wide visibility. So kind of the first step with APAVS would be going into the tool network and first extracting all the data. So this first you'd run this script on a PowerShell, and this script is gonna has a JSON of the config containing all the CSV tools currently. That will be expanded later on, and it'll first ping the tool, connect, it'll find the zip, it'll then parse all the data and then give a result kind of each run, pass, fail, or incomplete, where the sent data wasn't conclusive or taken. Uh, so it'll each connect to each individual tool, get the data, and at the end it'll give a message saying extraction complete. And then if a fail, if there's something unexpected happened, and the total time it would take. So this was completed previously just for brevity. You can see also then all these CVs then go back to the development laptop, and are then another script is executed, which is completed beforehand as well. And then this would all insert all the data into the Power BI. So the Power BI dashboard is currently published here, which is accessible to all the technicians and engineers within Intel, so they can come in and view this data. So, so first we land on the APAVS fleet dashboard, which kind of gives an overview of all the tools and the runs, the number of tools, and then the pass rate. So here you have kind of like the slicers, which you can filter by the tool ID, the overall result, and then you have kind of conditional formatting both in the runs down here and to the right, where you can see the tool ID, the port name, and everything else, and also the run data, the run date and time. Second, we can go to the tool detail view, which will give more specific details out to kind of individual fails and which load port they occurred on, and also the slot number they occurred on. So first we can just go to CSV 201, for example, and we can see where the fails have taken place. So the y-axis currently we have an average of the offset, but then you can go into the slot number and kind of distinguish which slot number is actually given the fails. So we can see here there's a fail there in slot 6. So then the technician can go back into the fab and then do a reteach of the load ports, and then hopefully come out with a better result when retests have been completed. There is currently limitations with this. See here, there's kind of like a temporal offset, which the thought value at the moment, like from like December to January 25th, these results were passing at the time, but because the thought value wasn't kept, these will be recognized as fails by the system. This is a problem kind of exists now and on the previous macro, but this will be resolved in the future. Uh, Another kind of a benefit of this system is that it does like the fail and incomplete and passes. So the incomplete, so previously for tools we were getting many fails, and it's kind of unsure why, but then it was kind of recognized that it wasn't actually an issue with tools. It just was getting no sensor data back. So that kind of bring in many instances the fail rate from 50% to only 1%. So this was just a quick overview of the APAVS system. It kind of delivers what previously existed, having to um, connect to each tool individually. And now it has persistence also, so anybody can come in here and just load a link, where previously you'd have to go into the tool network and complete um, many different Excel macros side by side, and there'd be kind of no collection of data in the end where it's stored. So thank you for viewing my presentation.